Hi there! We now know that platform independence is one of the key benefits of Java. But before understanding how Java achieves platform independence, we need to first understand what platform dependency is. To understand platform dependency, we also need to know what compilation is. Compilation is a very fundamental concept in computer science. If you are new to programming and not completely sure about what compilation is, this short discussion on compilation should be helpful. Let's start with the absolute basic concepts of a computer. Every computer has a fixed set of instructions which it understands. And a computer program is made up of some of these instructions. That is, the instructions help a computer program to perform something meaningful. And each instruction is basically a sequence of zeros and ones. That is, an instruction has a binary format. Such instructions that computer understands is called as machine language. That is the language which a machine understands. Machine language is also referred to as machine code and is sometimes also referred to as native code. And here is an example machine instruction which tells the program to do something. Now, as you may imagine, it would be an extremely difficult task for programmers to write programs in machine language, which have only zeros and ones. So it's got to be simpler than this. So computer scientists came up with another language called assembly language, which was much more easier to read and write. Here is an example to add two numbers, which for sure is much more expressive than machine code. So assembly language provides certain higher level notations for writing instructions. But computers understand only machine language. They don't understand assembly language. So there is a program called assembler which translates assembly language instructions to machine language instructions, which a computer can understand. Now both machine language and assembly language are referred to as low-level languages. And that's because they use low-level details of a computer. One example would be specifying the memory location where we are storing data. And writing programs even in assembly language is still tedious. So programmers wanted programs to be expressed in a more easier way. And they also wanted to hide the low-level details. So in time, they came up with high-level languages. And some example high-level languages include Fortran, C, C++, our very own Java, and C#. And they use English-like words, mathematical notations, and punctuations to write programs. So they are much more easier to write and read, as we will see in this course. And of course, they also hide low-level details of the computer. So today, we mostly use only high-level programming languages. Assembly language is not used very much and is used only where performance is critical, like in the case of operating systems of electronic devices. And in terms of terminology, source code is the term that is used to refer to any code which is expressed in a programming language. Now, like in the case of assembly language, source code cannot also be understood by a computer. So we need to translate source code into machine language. The translation from source code to machine code is done by a program called compiler. Machine code, which is the executable program, is then executed directly by CPU in a separate step. Note that in this illustration, we are calling the translated language as target language and not machine language. And that's because in some cases, it may be something else too. For example, in the case of C or C++, target language would be machine code. However, in Java's case, it is Java bytecode, which will be discussed later. Sometimes target language can also be another programming language. There are some core operations that a compiler performs, and let's see what those are. Verifying syntax and semantics of the source code is one of them. This ensures that the source code complies with the rules of the programming language. For example, a program is made up of statements, and in case of Java, every statement must end with a semicolon. Now, if a statement doesn't end with a semicolon, then the compiler detects it as a syntactic error and reports it to the developer. Compiler also performs certain code optimizations for faster execution. Okay. Finally, it generates machine code from the intermediate optimized code. A compiler is a very complex program, and these core operations are basic operations that any compiler supports. As you will see in this course, a Java compiler performs tons of additional operations to ease the programmer's task. So the compilation process can be slow due to the complexity in translation. However, once compiled, machine code execution will be very fast, and the machine code can be executed anytime and any number of times. Any change to the source code requires complete recompilation. Next, we will look at platform dependency, which will also give you an idea on how a C program is compiled on Windows and Linux machines. We are not going to write any code for this discussion, but towards the end of the chapter, we will write, compile, and execute our first Java program. So in this chapter, we will write only one program. But as the course progresses, we will write lots and lots of programs. And every concept that we learn will be demonstrated through demo programs. So that's about it. Thank you. And next we will look at platform dependency.